Welcome to section 7.2. In this video, we are going to be learning about how to solve this thing called proportions. So in the previous section, we learned what ratios are and how to apply them to real-world scenarios. We also learned how to determine if two ratios were equivalent or not. Now, if we have two ratios that are equivalent, we can set up this thing called a proportion. So a proportion is a mathematical statement or equation that says two or more ratios are equal to one another. Now, one thing just to note is that proportions are generally expressed in fractions. So in the following examples, using ratio equivalence, determine if the following proportions, or determine if the following are proportions. Now recall what a definition of a proportion is. So remember, a proportion is a mathematical statement that says two or more ratios are equal to each other. So what we're doing here, basically, is we are determining if these two given ratios are equivalent. And if they are equivalent, then they are proportional, essentially. So sometimes ratios we seen in the previous section, they were expressed like this. But ratios can also be expressed in fractional form. So this 2/3 is a ratio. And we can write this out as 2 for 3, or 2 to 3. But most of the time for proportions are not written in ratio notation. They are written in fractional form. Okay, so with all that being said, let's work through our first example. And I encourage you to pause the video and to see if you can figure it out on the first go. And assuming you have given it a go, let's go through it. So what my first step is, or what I would want to do as my first step, is to see if there's a common number that we can multiply both the numerators and denominators by. And if we look at this, we have to think to ourselves, what would we multiply or divide 2 by to get to 4? And in this case, if you're thinking, well, you can multiply 2 by 2 to get to 4, you are correct, because 2 times 2 is 4. And then if you look at the denominators here, or the bottom part of the fraction, we have a 3 and 6. And to get 3 to 6, we can also multiply it by 2. And therefore, because these ratios are equivalent, we can say that these are proportional, or they are equal to each other. So therefore, they are proportional. And therefore, we have a proportion. Now, you might be like, okay, what does this actually mean? Well, what is helpful maybe is to look at these fractions as a decimal. So if we put 2 divided by 3 in our calculator, you will get, so 2/3. If you take 2 divided by 3, you'll get approximately 0.66 repeating. If you don't know this line I just put on top of the 6, this line means repeating. So 0.66 repeating. So 2 divided by 3 is 0.66 repeating. And if you take 4 and divide it by 6, you will also get approximately 0.66 repeating. So since these two values are the same, we can say that they're equal to each other and that they are proportional. Okay. Looking at example 2, I encourage you to pause the video and work through it. And assuming you have given it a go, let's work through it. So to get to 4 to 8, what I would do is I would multiply by 2. But to get to 1 to 4, you can't multiply by 2. You would have to multiply by 4. And because we're multiplying two different values to the numerators and denominators, these two fractions are not equal to each other, and therefore they are not proportional. And then just so we can see, if we were to do the decimal approximations like we did above, 4 divided by 1 is just 4, and then 8 divided by 4 is 0.5, and 4 is not equal to 0.5. I'll actually write that same thing up here. 0.66 repeating is equal to 0.66 repeating. Just gonna write that up there. Okay. But anyways, now that we got an idea, I encourage you to pause the video and work through examples 3 and 4 on your own and see if you can determine if they are proportional or not proportional. Now let's work through it. So to get from 10 to 5, what I would do is I would divide by 2. And to get from 6 to 3, I would also divide by 2. Because we're dividing by the same value to both the numerator and denominator, we aren't changing the value of the fraction. We're just simply reducing the fraction, actually. And when we reduce the fraction, we still get the same value. So therefore, these two fractions are proportional. They are proportional to each other, or one another. And now for this final example, example 4, to get from 12 to 24 for this first set of fractions, I would multiply it by 2. And to get from 24 to 48, you can also multiply by 2. So this first set is equal to each other. And then from here, what you can do to get from 24 to 1 is to divide by 24. And then to get from 48 to 2, you can also divide by 24. So since we're dividing by both the same values, this is also equal. So since all of these three fractions are equal to each other in value, they are also proportional to each other. Okay. So with all that being said, now let's start to get into this idea of solving a proportion. So basically when we solve a proportion, we are solving for an unknown value, or in other words, a variable. And also thinking about this as how we've been looking at equivalent proportions actually already, you might be able to just guess what this missing value of x might be just by looking at this. And you can think about it as, okay, well, to get from 3 to 6, we're going to multiply by 2. So therefore, to get from 5 to x, you're going to want to multiply by 2. And we could then say, well, x would have to equal 5 times 2 then. And 5 times 2 equals 10. So with that, let's see if this logic holds true when we actually solve for x. Because what we're going to do here to solve for x is we're going to do something called cross multiplication. So we're going to take this 6 and this 5 and multiply them. So 6 times 5. And then we're going to set that equal to 3 times x, or 3x. And then from here, we're going to solve for x. So we're going to do 6 times 5, which is 30. We're going to set that equal to 3x. And now if we recall in solving linear equations, to solve for x, we're going to divide 3 on both sides to get x alone. And we're going to get x equals 30 divided by 3 is 10. And as you've seen earlier, we did logic through this. And you can actually logic through some of these problems. So that's kind of like the logic behind it, why we get x equals 10 as an answer when we solve this proportion. So with that being said, I encourage you to pause the video and give this second example a try on your own. And let's work through it. So I'm going to cross multiply again. So I'm going to do 8 times y. I'm going to write this on the side. So 8 times y equals, and then 7 times 2. So I'm going to write this as 8y, and 7 times 2 is 14. And then I'm going to solve for y by dividing by 8 on both sides. So then we're going to get y equals 14 over 8. And then since 14 and 8 are both even numbers, I'm going to divide by the common factor of 2. So you're going to get, as your final answer, y equals 7/4. Okay. Looking at example 3, we're going to cross multiply. Right. We have example 1 here, example 2 here, and then example 3 is over here. I do apologize, it is a little messy. But example 3, so we have z times 11, or 11z, and then we have 4 times 3. So we can rewrite this as 11z equals 12, and then to get z on its own, we're going to divide both sides by 11, and we get z equals 12 over 11. Looking at this example, let's cross multiply, or example 4. Write that over here. So we're going to get 5 times 5 equals 10n. So we're going to get 25 equals 10n. And then to solve for n, we're going to divide by 10 on both sides. And you're going to get n equals 25 over 10. And we can reduce this fraction by dividing both the numerator and denominator by 5. So therefore, our reduced fraction will be 5 over 2, or 5/2. Now, looking at example 5, this one does have one more additional step to it, but it's the same exact process as we've been doing before. So I encourage you to pause the video and see if you can get this one on your own. And assuming you have given it a go, let's go through it. So we have 6 times 7. And then we're going to set that equal to 3 times 2x. Now on the left-hand side, 6 times 7 is 42. And then this here, we're going to multiply this 2 by this 3, so you'll get 6x. And then, to solve for x, just simply divide both sides of the equation by 6. So you get x equals 7 in this case. And that's your answer. And then looking at our final example of this section, let's cross multiply. So you're going to get 4 times 8 equals 15 times 3y. So 4 times 8 is 32, and 15 times 3 is going to get you 45. So we have 45y. And then we're going to divide both sides by 45 to get y on its own. So we're going to get y equals 32 over 45. And this fraction can't be reduced. So this is your final answer.